Are we
What?
going
Are we live? Yes, we are. Alright, good morning everyone. Welcome to the second edition of our Developer Jam. Unfortunately, the first time we couldn't go through with the live stream. There was a problem with my broadcasting software over here. So, what I'm going to do is today, because we couldn't cover the live stream the last time, I'm going to quickly go over the overview of what we had covered the last time, and then we're going to quickly jump into what we're going to cover today. So, the project structure is actually on the GitHub page. If you're not aware where the GitHub page is, just go ahead and go to the GitHub repository of BlockVigil, and there is a repository called To-Do App MVP. Okay, looks like there's an echo problem. Alright, seems to be fine. Sorry for the distraction. Go to the BlockVigil repository on GitHub. Right on the very top, you'll see To-Do App MVP. What you need to do is take the link and go to your terminal. And clone the link from the repository. So under clone or download, get the link, type out git clone, go ahead like this, just press enter, and I already have this cloned, hence I'm just going to move into the directory. And once you have the directory cloned into To-Do App -MVP, open up the Visual Studio Code. It's distracting me. So open up the Visual Studio Code. Or if you're using Atom, that's fine. Make sure you open, in my case this is the one. So here I am. Alright, the way to get this operational is once you cd into it, there are a few modules. So you'll need npm node.js installed, so I'm assuming you do have that installed. We had posted it in the requirements, so just go ahead and do a npm install. Okay, looks like I could paste the link over here. Once you've done an npm install, the quickest way to get this running is just type out npm run dev and press enter. So as you can see, it opens up on the 3000 port, and for this specific example I have my demo running at 3000/2do. Okay, something like this. So I was already working on a little example yesterday, so that's why you already see an entry that's over here. And what you see over here now I want to take you into the code of what's going on. So under src you have routes, and then you have todo.svelte. So in todo.svelte you have the dynamic JavaScript code right here within the script tags, and then you have the main UI container. I'll quickly go over what you see over here. The place where you go and enter and type out your to-do note, what you see on the screen over here, is this form, and it's wired on to handle a submit event which causes a to-do to be added to the smart contract. You'll see about that. And then you have the actual entries over here called a to-do list class, and that kind of fetches the data and starts listing them over here. So this is an unlisted class, unordered list class, and we iterate over a certain array and start displaying them over. The dynamic part of the JavaScript, I'll come to that later. I will first show you where the data goes to be stored and where do we update it. So it's in this contract called to-do list contract. So just look for this file called to-do contract.sol for solidity, and there are these obvious functions over here. You have a function to add a to-do item. I won't go through too much of the details in the solidity code. It's pretty straightforward. You have a item ID against which you store a struct, and that holds the actual note is held over here. So when you do an add to do, that's what is created as a structure against an event ID. Similarly, you have a remove to do. Of course, the thing with blockchain storage is you can't delete anything as such. So what we have done is, as to just make sure that that won't be rendered in the front end, we just set a string that will check on the front end that not to render such a thing. And of course that means the note is overwritten technically, which makes it redundant, that you don't have to delete it. The add and the remove are the pretty straightforward functions, and then you have get all the to-dos. So this is what you see happening when you load the page in the beginning. So you have the entire array returned one by one when you call this function. And we do have the option later on, if you do want to just get only one to-do item. Of course, this is the mapping from which you can just specify one ID of the to-do item and get the corresponding structure of the to-do item, which holds its string note and the status, whether it's deleted or it's redacted. So here, as you can see, when you call it remove to do, I make sure that the status is set to false. Alright, so that's the smart contract. But going in to the JavaScript functions, so let's see what exactly happens, which get called. It'll take like 5 more minutes to go through what's happening. So right here is what is called when the todo.svelte over here, this component is initialized. There's a call straight away to get all to-dos, which happens to be here. Now the making the call to the smart contract, this is what I'm doing right now. I am calling it on the Ethereum APIs, so which exposes the same contract that we deploy and the function underneath it as a web service API. So this is exactly what I'm constructing. Ethereum API prefix, if you want to find out the configuration, it's right here. All API calls to Ethereum they are constructed with this API prefix. Once you have this, you have slash contract slash the contract address, which is once more specified right here. Wherever we deploy the contract, we have to specify the address into the config file, and then I add the final path qualifier, which is the contract call called slash get all to do. This is the same function that you saw within the Solidity file. The Ethvisual API gives you an access to the function like that. So that's what we call and make a HTTP GET call to it. This returns you a big list of data structure, which I'll take you through in the interactive web UI of Ethvisual. That will make a lot more sense. Where are all the to-do items stored and how are they returned from the API in a certain data structure. Let me take a look at what our current contract address is. Right here. Alright, I have this here. So I'm going into the Swagger UI for this contract. We already deployed it last time. If you do wish to deploy it once more, it's very simple. You need to go to Remix. You take the Solidity contract code, you paste it here, make sure to-do list contract stays selected, click on the violet button over there. This takes you into the deployment phase. Once you click on deploy, just wait for a while. You will see a transaction confirmation come up. But once you have the deploy, I will first show you what did we have actually as the listing of all the get all to do. So my previous contract got deployed. Don't be worried. This is what you're seeing. So I was trying to take you into the contract where I had already put a few items so that I could show you how they are returned from the Ethvisual API. So I'm going into the Swagger UI for the contract I had deployed already. So here's the get all to do. As you can see, I'm going to give it a call. Yes. So this helps you kind of quickly test out your smart contracts from the live web UI. The return comes as a JSON data structure. So as you can see, success is true. And in the data, you are returned an array. And within the array, we're actually giving you as a mapping the return type. So right now, the reason that you see this is the return type is a structure. And within the Solidity contract code, when you see what I return and get all to do, right here, it returns a dynamic array, and we don't have a return variable name specified. So if I had indeed done something like this, then we could have gotten a name onto it. So don't worry about that. That's not constraint right now. All it says is because we didn't find a name while we were parsing for your return variable name, we just found the type definition. So we have filled up the return key with the type definition just to make things standard. And against this key, you finally have the return value. So right now we do have only one to do. Hence you see only one return that has come through. I want to show you what would happen if you have a couple of more to-do items in the list. How would a get all to-do look like? So just give me a couple of minutes while I enter two more items. So go over to add to-do, try it out, enter an item. This should return you a valid transaction hash. Let's enter one more. The previous transaction went through. There's an event. We'll look at what this event does a little while later. Alright, so I entered item 02 to do item also, and you have this transaction hash which also got confirmed. Great. So now when we do a get all to do, observe over here that you have all these to do items returned within a list, and each of them, because they are a structured data type, they are also an array, right? So you have the timestamp as it's defined in the struct right here. You have the note and you have the status right here. So alright, so you have the get all to dos returned just like this, which makes it very easy to parse it on the front end. So on the front end, all I'm doing is when I'm calling get all to dos in todo.svelte right here. So once I'm calling get all to dos, now you see what I'm doing over here is I'm just taking out the data list by accessing the value against this key right here. See this? So this is a data type which has been filled in as the key string, and against it we have the list on which I'm iterating with something called a for each loop. And as I'm going through each loop, I check whether the redacted string is around or not. If it's not redacted, I just parse it and I add it into a JavaScript array called to do items right here. So the definition begins over here, and one by one, once I'm going in to get all to dos right here, I loop over and I start filling up the to do items. That's all that is happening. It makes it rather easy to parse. It's a complex structure, but when you get it as properly a JSON API, it makes it as easy as a for loop to render it. Once you have the rendering part going through, now you have the function that I did from the interactive UI called add to do, but I had connected it somewhere, right? If I look at this, by the way, I hope you observed that since I have been interacting with live over here, I also have the items getting rendered live right over here. So that's the part that we had built during the last workshop, where no matter where you enter the to-do node from, so it could be from a mobile device, it could be from somewhere else, the UI should get updated live. So that happens through a WebSocket service. That's exactly what I was going to go into anyway right now. What we had done is somewhere we catch WebSocket events. So I'll take you to that specific function model right over here. So there's a part where I'm doing something called a WebSocket transaction store. So this is our internal definition. I'll show you where it is being written off. But know that when I call a dot subscribe, it's basically that as if I'm catching the WebSocket data coming in, and as I put it into a store, the update logic of the UI can be written into dot subscribe. Every time there is a new value entered into the data store on the UI, I can cause an update to happen, hence the dot subscribe, and now you'll see the logic. Value is nothing but the exact WebSocket payload that comes in. I will do a add to do once more from our web UI that we created last time, and I'll show you what this value holds. This value is actually an entire JSON payload, and we have a certain payload type which we check. So if this is an event payload, which happens when you call add to do right over here, I'll take you to the event also. Right now I am in the solidarity file on line number 23. Every time you add a to do item, the smart contract emits an event called to do item added, and the ETHVigil APIs ping back your front end with a WebSocket payload. we have this happening inside init WebSocket. Won't get into the details, but know that it sets up a WebSocket stream for you, right? And it is configured, of course, with your API keys. I'm assuming you have already gone through the GitHub profile to know that what these API keys are and where to fetch them from, and to make sure that even before running your app you have updated the rollup.config.js. Anyway, so once a new WebSocket payload comes in, then I start checking whether it's an event payload, and as you can see that I now do a check on what happens to be the event name that has come with the payload. To do item added, we saw that it gets emitted when you call add to do item. Hence I check that okay, this is a new item that has been added. I make sure this is exactly where the to do items array gets updated. So this is exactly what I'm doing, which causes the reactive definition over here, what you can see, where I have wrapped it around this template JavaScript of sorts, where I can go through the to-do items like a for each loop. Every time the to-do items object changes, like this, every time there is a change, that reactive definition is executed once more. So I do not have to worry about writing too much of a UI update logic. I can just be totally secure that I'll get a WebSocket upload as long as I have done the call to the smart contract. So as a front-end full stack developer, whichever role you work as, your work becomes much less if you do not have to worry even about where the WebSocket payload came from, did the event get updated. You don't have to do anything. All you have to do is just catch that data and put it into an array. The rendering should happen. Ideally, you should just give it off to a UI engineer to make sure that part of the element gets written, while you can work with most of the backend interfacing logic. So that's like the separation of concern that you can achieve when you have an API that's handling most of your decentralized calls. And there is a little bit of a nice UI effect we had called pending transaction. So every time you call a add to do, we set a pending transactions, and once it goes away, there is a nice effect over here. As you can see, we'll see it in action right now, what happens here. And I'll also make sure I keep the debug console open so you see what's going on. So let's see, I'm going to enter one more item, call item 03 like this. So just to make things easier to understand, I have been debugging. By the way, that was a really fast upload. As you can see, I received a WebSocket update, and this is how the entire payload looks. As you can see, this is exactly what I had written in the code, where I was checking whether the value dot type is an event. So the type happens to be here. This is the field I checked, and within that I check the event name. I'm checking the event name is to do item added, and then once it's to do item added, I'm taking from the event data the item ID and the actual string note, right? Event data, I'm going to expand. As you can see, note, it actually gives me the string that I entered over here, item ID as it has been stored on the contract, and it gets updated. Pending transaction is checked against the WebSocket upload. So you can write a stateful. Stateful means the UI should know what has happened in the past. So this is exactly what I have done. I have stored it into an internal variable called pending tx right over here. So when the add to do event handler is called from the UI, I call the function to BlockVigil API, and that sets up a pending transaction internal variable. Once a update comes in from WebSocket, that also comes in with the corresponding transaction that happened on the Ethereum network. I check, and this gives a nice cool effect. So let's try it once more and see how the effect can look like. So once you enter, I have a check whether there is a pending transaction, so I render the same on the front end, and only when the corresponding WebSocket upload comes through, I make sure that that gets cleared out. So just waiting for the next WebSocket upload. Yeah, so a new WebSocket upload came in against this item 04. You could see how the pending transaction was removed, that waiting message got removed automatically, and a new item got rendered. All of this happening within let's see how many lines of code, like just this, like that's less than 20 lines of code to render, which also includes deleted items, and just 3 to 4 lines to show that there is a pending to-do item or has it been confirmed on the chain. This is pretty much what was covered last time. Add to-do, what I wanted to tell you is this add to-do JavaScript function is connected to line number 194. You can see the form on submit. So basically when I press enter, add to do is the function that gets called, which forwards the call to the BlockVigil API right here. As you can see, I kind of parse the text box data, and then I call this function called post to do, which is nothing but making again with that BlockVigil API call, but now to a different function, add to do, and it's a HTTP post call. That's the difference between get all to dos and post to do. Get all to dos was a get call because it's a read call. So that's how BlockVigil APIs expose these contract functions. If it's a read call, we give it to you as a HTTP get call, and right over here when I'm doing a write call, which is basically will send a transaction to the Ethereum network, it's a HTTP post call. So nothing specific over here. The API key is necessary to make a post call because you're going to make a write call to the network, and it goes through certain identity signing mechanisms on a platform, which is why we need to identify you. Once the transaction goes through, as you can see, I get a transaction hash out of this, which is stored into the pending TX. So that gives it that nice cool effect that the pending transaction is stored in a value, and if that happens to be there, I render it saying that okay, I'm waiting for this transaction hash, and when a new WebSocket payload comes in, I quickly set this pending transaction value to null, which causes this to transition out. So this is a Svelte powered transition, so it looks cool, it just goes away. And because the to do items gets updated, you again have this reactive iteration getting rendered once more. It's a very easy way to code a front end, and especially when you have live update of data, it makes your life easy as an application developer. So now it's mostly about your creativity than being constrained about okay, checking whether my transaction has gone through, the event that has come in, how do I need to parse it, nothing of that sort, right? So these are the exact details that were covered. I guess it was necessary for us to move on. So this time, as you can see, there should be a way to mark these to-do items as done. So the done status in our contract, we have it stored like this. So the status should be set as true when you say that it's done. And we have a function corresponding to that called function toggle to do, which you can see it kind of flips the status, and the same should be also updated on the UI, which is what we'll take a look at in a bit. So there is quite a bit of coverage, so I would just give you about 5 minutes to quickly run this demo for yourself, right? Go with the GitHub repositories instructions right here, where I have laid out how to fill up the rollup.example.js into a proper config.js file. First, you have to rename it and enter the right API call and the read API key over here, and make sure you deploy the Solidity contract. If you haven't deployed, you can also go through the instructions over here. Make sure the config gets filled up, and then the steps of installing npm and then npm run dev. Finally, you should have a running web page. That's where it should work. So localhost 3000/todo, you can start adding things, and you can keep the inspector console open to see whether these things are happening for you. So we'll just take 5 minutes off while you try to get this example up and running for you, and then after that we'll take a look at the toggle to do, which will set item as done. So the idea is to render this nice little circle as a green icon, and once you have the toggle, we'll take a look at whether the delete to do operation can be done into a live update. So once basically a delete happens, this should get refreshed. You shouldn't see the deleted item on the UI. Yeah, so we'll just take 5 minutes off for this. Do we have any questions? By the way, if you're still looking, if you go through the todo.svelte, if you want to know where the design came from, I have linked it in a comment over here. So it's a nice little blog post also that can teach you a little bit about building a dynamic UI. So it shows you the full thing with the JavaScript, but here we are interfacing with the API gateway to submit calls, to check for updates back from the Ethereum network. So it's a little different, right? But it will give you some idea of how we have adapted this. You can adapt any front-end example written in vanilla JavaScript, written in Node.js, and you can just adapt the backend calls to be made to the BlockVigil APIs for the storage and the logic update to happen on the chain, while you get the activity update through the API gateway through WebSockets and do a dynamic update, right? So yeah, I'll give you some time to get the demo running. If you have questions, if you have trouble running the demo, you can post any concern on the YouTube chat, or you can join our Discord channel. It's a nice little example. So this JS stick over there, right? This is the one that has to be marked as green, something like this. Tick. This will be the UI update. Is it This is the exact part where it's just yeah. Okay, so take a few more minutes. We have questions. Smudgy ones. Okay, let's move on. Let's move on. Okay, this is live stream. Okay. What? Sorry, there's a question. How do I ensure data on the to-do list hasn't been tampered with? So, see, the thing is, like, when you are calling add to-do, right? Each of them, we saw they have a transaction associated with each of them, right? And every call that you make to change the state of the to-do item, by the way, in this code, we just have what we have over here is a remove to do call which writes over. That is also going to be available as a transaction, and same with toggle to do, which sets a to do item as done or not done. The same thing is also available as a transactable function. So any changes that you're doing, that is available as a transaction. Tampered would mean as if you don't know that a change has happened. That's not going to happen. You'll always see what is going on the smart contract and know when a certain transaction has altered the state, right? Every call comes with a certain item ID, whether it's remove to do or whether it's toggle to do. So any item ID that has been altered, you can see it as a public transaction, right? Does that answer your call? Swaroop, does that answer your question? I think there is a lag, so we are going to move on. Okay, he got it. Thanks. We are going to move on with marking the to-do thing as done. So what we do have in this list over here, let's quickly look at this element over here. How is it exactly? So this is a list element right here in li, right? And the entire thing is of course unordered list. It comes without numbers, and within each element this is wrapped within a li tag right over here. Now there is something over here that's handling these clicks. These are called event listeners. We have a little bit set up in the code already, so I would try to take you through that. There's this function called handle list click, and I'll also show you where exactly is it doing the event handling. Right over here on line number 203, I have on the entire list element, I have an event handler saying on click. Why do I have it on the big li tag and not within each of the either the checkbox or the delete cross button? Why don't I have it on that? We'll see that right now. So when you have this click element configured on the li class over here, now I can see where the event target happens to be. So this was specifically handling the call to the cross button, right? That's why it's called JS delete to do. Let's see right here. As you can see, the cross button that you see over here has this class JS delete to do, and that's exactly what I'm handling over here, right? So I'm checking. Similarly, if I want to handle a click on this element, which is basically coming with this class called JSTick. Tick is of course also another class assigned to this. So this is the CSS class for this label over here called JSTick. So I can handle a click for this specific element, right? Right here. See this? Yeah, I think it's visible on the UI. So this is the element on which I should be looking out for click events. So I'm going to add another clause over here. So because I'm adding if there's similarly, let's try to add one more clause. If you are following along with the coding, it would be also nice if you could do the same. Okay, what is this called? JSTick. JSTick, yeah. Okay. It's the same concept. If you are a JavaScript developer already, you might be able to even follow along the original article from where I took the UI design and the behavior. This is where it's available. Let me just quickly post it for you, just in case it's easy for you to follow along from a different source as well. Yeah. Alright. So it's the same approach. It's just that they don't have any calls to the backend happening, just to reduce the confusion in case you wanted to know where this comes from, right? So anyway, the JSTick is the element on which we make the call, the click I mean, not the call, the click, and the call comes to handle list click, which I'm handling over here, and then I'm checking whether JSTick happens to be the source of this click, and then I'm going to update. So there's a section over here where I'm taking out something called parent element dot dataset dot key. I think this will be a good time to take a look at why is this happening. Just increasing the font, maybe it will be easier for everyone to follow along. Yeah, and right here when I am creating this list class, there's a data key that I'm setting, so data dash key, which is the to do items mapping ID on the smart contract. This can be accessed within the handle list click. Like this. Parent element, which basically just says that this is the button and its parent happens to be the li class dot dataset dot key. So the dash key that is available within the dot dataset dot then the string. That's how I pick out and I know which element has been clicked, because this is the item key I have to send as a toggle to do call to our Ethereum backend. Right? Just to make my development easier, I'm going to put a debug message. Key. Yeah. Now the best part is I do have to write out the backend call that happens for toggle to do. So let me just quickly make the framework for that purpose. So it's like just copy paste this without wasting much time. Yeah. That. Okay, now we do need to write something like which is not defined yet. So let's see what we can do about that. We have a delete to do. Similarly, we'll have to write toggle to do with the item ID. I didn't write this deliberately beforehand. I just wanted to make sure we go through this live. It will have a similar structure. I just need to change what goes on in the function call. So I'm just going to take the help of the delete to do, which is written last time, and enter it here. So this one will be called, but toggle to do shall be called. So the parameter being passed for toggle to do also, let's check this out. Now try code, it expects only one parameter called item ID. I'm passing the argument from there. So toggle to do has come from the list click. I have gotten the item ID and I'm passing it as an integer with the right API header, and this should go through as a transaction. That's all I have to do. And of course I have to also handle when this emits a to-do item updated when it comes through as a WebSocket event payload. I got to handle that also, right? So we'll take a look at that. So that's all that it actually took to make the call to toggle to do and handle list click event. Then I have to start handling the UI update logic. Let's name something like just keep things and see why we are doing this. It makes things easy to render differently on the UI when you want to show different things. So alright, we have to define these two variables. We haven't declared them yet. Somewhere here. Yeah. Update key and pending update transaction. It's important to declare them. Once you've declared, there is a handle list click for that. I have checked whether it's in the JStick. Alright, so this will just send the call. The UI update won't show up yet because of course I haven't written anything. I have checked on to do item added, I have checked on to do item removed, but I haven't checked anything for to do item updated. We will look at the dynamic behavior later on, not yet, right? And also let's try just a little bit of things. So I'm checking as I'm iterating through the list of to do items. I have a check whether item is pending deletion or not, and I kind of render it with an extra note like this called pending deletion. I also want to check whether it's also pending updation, maybe. So that could be a right way to do things. Alright. So first let's check whether the call to the backend goes through or not. So I just save this file. That should reload the dev server, and then I come back over here. Let's try to click on this. It did get a toggle action. It has made a call to toggle to do. Right. So we did receive a WebSocket update as well. That's great. With the to-do item updated set as the event name. So amazing. Which means our updating stuff is working, right? It's just that when you don't have a UI logic written to catch this WebSocket, of course you won't see. And then we also have to ensure that when some status is set as true, this should show up as a check box, something like that, right? Alright, so let's take a quick look at what do you do when you want to set the checkbox. This is kind of what you have to do. We kind of select the to-do item, and this is a pure UI rendering. When you see a item over here and then add something called done, then the checkbox gets rendered. So that's exactly what is happening, right? So the done class is added or removed. So when I added done class, a CSS class, not to confuse you, when a done class, a CSS class is added to that item, list item, then it gets rendered as a checkbox, right? So as you can see, this class has the effect of striking out the text and showing a check mark in the checkboxes of completed items. So this is exactly what we're trying to achieve when we catch the to-do item updated event, right? So let's get on with that. We have yes, right over here. Case to do, let's copy paste the right. I'm going to copy paste the right event name. Where was it? No, I refreshed, sorry. So to do item updated, that's the event name. Update from for now. I'll just put a debug message. Do a little bit of copy paste from here. Something like this. But already have the updated ID, remember that. Just to make variable names, select it shouldn't be access this. Just trying to think, how do I pass this updated ID over here? It shouldn't be a $ID, it should be this. This doesn't let me ask Swaroop. Let me ask Swaroop how to get this. How do I? I'm just going to ask my colleague Swaroop. I'm not a JavaScript guy, so. The idea being, once I get this list item over here, I can do list. This is all I need to do. What I'm trying to do is do a substitution of the JavaScript variable over here. So I'm not too familiar with this ES6 way of doing things, and I'm coding it live, so I need to find it out. I want to do go to select what do I do if I have the key? Let's see. If I want to select something, is Swaroop online? Let's try to run this. We'll see what comes up. Okay, I'm trying to check how do I keep this item status and then add a class as done so that it comes as a ticked item. So right here, the return happens to get the status field as true, right? Over here. So I'm trying to make sure that the return data structure that has the status set as true should have a class list as done, right? Yeah.
Yeah. So basically, Sonic was asking if he wants to know like what exactly is.
Okay.
Anything else that's there, so
Yeah, okay. Alright, I'm just trying to coordinate with my colleague here regarding the JavaScript thing. So on the true over here, if they can,
can you pass me that line where you made an updated item and then you updated the query solution?
yeah,
Yeah,
this part.
this.
So you have this JSON. I'm trying to do this here. Within, so I'm trying to do a query selector with the data key passed on with the updated ID. That's one, and the second thing being, let me send it to you. Right here. So this is one thing, and the other one that I'm trying to do is, as it is rendering right now, as it goes through each to-do item, so whenever it gets a item like this where this status field is stated as true, when it's set as true, it should add up the class called done. So like without anything, if I just do this, you'll see something like this happening, right? So there has to be a check on to-do items like this. If this, I can always get a separate, I can always do this. Whatever I described it as checked. It's true, yeah. Checked. So when it is like this, then sure. Or it happens to be something that's pending deletion. Okay, let me remove this. I have a better way to do this. The power of reactive updates make sure that like this. I think I should add. If item checked is false, and we have this checked over here. It is not liked. This is one of the issues. I cannot do this, and so this is what I had faced. I had to act. Now I realized the delete made sure that I have to put the entire block as well, entire list block definition I mean, and not just this. So something like this. So you cannot just separate out just like that. And I have to redefine the this. I'm going to set this done. Check and let's see. Okay, all good. Yeah, so I managed to get the to-do item that is done checked as rendered. So this I could figure out by going through as I'm looping through each of them. So at least on the first load, you'll see if an item has been checked as done, it's checked as done, right? What we're trying to do next is get this live dynamic behavior where once I catch the WebSocket update for a to-do item updated on an item ID, I want to make sure that this document.query selector, I want to make a item ID specific selection. And I'm trying to think which way can I substitute this update ID over here. Let's try to go. I'm going to wait till this. This is one of the ways to do it. Okay, let's see. At least we can click on and toggle action. And let's see what happens when the WebSocket update for the same comes through. I did get it to the item updated. So you do have this, but yeah, list item I didn't check whether I'm actually getting something. As far as I know, this is a React way of doing this. Somehow I have to substitute this variable over here. Let's see. We're running out of items to click as done. Do you have any questions? No, we don't. Alright. We did get a reply from WebSocket. Yes, updated item ID 2. Yeah, we are at 2. Okay, so do not, of course this is not working. How do I do a dynamic select on this? Yeah, I know, we can't use it in Svelte. So which way should I use it? Now I'm not very a JavaScript developer. Which way should I do it? Yeah, I can update the data structure. Does it mean that I have to reload it? Okay, fine. So what I'm going to do is, since I have the updated ID, never mind. I have the updated ID. So all I'm going to do is I'm going to loop. Yeah, I'm going through this thing. Okay. Like how I go through this with the index. I'm going to go through what is to do items.
I'm talking the exact one which is updated.
Sorry. Okay.
Try to do items.
Yeah.
Did the exact one.
So no, I was just trying to say like something like this, where we're going to update. Okay, as I iterate through, the idea is when I reach that index where the item ID has come, I'm going to do that, right? So I have to do items for each. Because I'm not a JavaScript developer, I have to also refer back to these things, right? So go to each of them and as some index equal to this. This is where how do I update the array? Yeah, and I have to update the whole object, right? So ideally I should be doing this where store updated to the items. Yes, this is how you store an array. Yeah, I have to do a declaration. Let this stay an empty array. As long as it's not the updated ID, I'm going to go ahead and add things over here. Push, yes. Yeah, push. So you don't even need to know JavaScript to do these things. Update it to the push element because this is exactly what I'm iterating over. No, it's okay, I got it. So if this is here, I'm going to do that. Otherwise, what was I setting in this? Checked. Yeah. So whether it's checked true or false comes from the event update and to do item updated. This is the status that is sent out. So I'm going to capture the same value. See, remember, it can be a check, like it can be marked as done, and again clicking on it should be marking it as undone, right? So I have to handle it accordingly, and I have to check that according to the event data payload that comes, okay? Right here. So updated status. I have to use this value.
So instead of using push.
So you have to check the updated status field from the event data, and you have to use it, right? So what status is it coming through, right? So data dot, what is it called? Updated status. So if it is true, right? If it is true and the updated status is also true, then you mark it as a check. Otherwise, it shouldn't be a check. You get that, right? So I'll set the checked as the same thing as updated status, right? According to that, the value should change. I'm just creating literally a copy of what is up. So I'm pretty redundant anyway. So actually this is the only bit. Like this. So if I have come into the same updated ID, I set it whatever happens to be the WebSocket upload that has come as updated status. Now this is where is it? This is a local array. I'm assuming if I reassign to do items equal to do items, this should cause a reactive update. Okay, break. Let's see, we'll find out. So I got the toggle action. We'll wait for the WebSocket update to come through. Yep, it's done. So that's what I did. Okay, this was the approach that I took to quickly break it down. I kind of moved fast, so that was my way. I deliberately wanted to do this live. I had not done this deliberately earlier, but this is what I did. I took out the updated event and I checked from the event data on which item ID the toggle update was called and the updated status that has come through, correct? So once I get those two values, I start iterating over the current to-do items, and if it happens to hit the exact updated ID, I just set its dot checked field equal to whatever the updated status has come, and then I push it into a local copy called updated to-do items. So after I'm done looping over this, I just reassign it back to to-do items, which causes a override of the object. And going into this rendered section, as you can see over here, if not item dot checked, I have a certain render for the list element, or if it is coming as a checked equal to true, then I have a done class added to it, right? So whether I check it as done or undone, now let's try to see. If I set it as undone, do I get the opposite effect? Toggle action. I want to see when the WebSocket update comes through. Did you see that? Item 01, the checkbox is removed, right? So we have managed to get a live update working as well. Now, how about putting a dynamic little bit of text next to it saying that it's awaiting the toggle status confirmation, right? So I would like to do that in the rendering thing. So where am I rendering? In this place, right? We have a check for that for deletion, right? So that means I have to now check a pending update key, right? This will take a while because I have to duplicate this block. So one of the issues here is because this is the whole list element, I cannot just write okay, if item checked and this, else only this line, and then keep the rest of it as it is. It doesn't work like that because this JavaScript framework it creates difference of HTML elements in the DOM itself, right? It doesn't maintain a virtual DOM, which makes it a little difficult to write it like a templating language. Where if I write this, like ideally I could have just gone and done this, right? Else, if I could have done something like this, other condition, and then make a different beginning of the list tag, I'd be much happier like that. But I can't do that right now. So that's why I have a separate check on item.checked, and then whether it is checked or not checked, the list definition changes according to that. And now within this, if I want to add another if condition, then again the whole thing changes, right? So now that I'm checking, well, within each of these I have to write that kind of logic, right? So it can be of course shortened by a different, maybe even a different UI structure, which makes it easier for updating. So that's something that you will know better as a front-end designer, how to lay out the elements so that the less amount of DOM updates, the document object model updates you have to do, the better it is, you know. So that's why I would just leave it as a exercise for something later. But as you can see, I have this thing running nice and good, right? So if I click on this, ideally I would like to render this as a different color or something when in between it hasn't received the final confirmation, and then when it receives and you see the checkbox is gone, right? So we got that thing going. And the last bit for today is so I have this thing called Airtable. Airtable is this amazing application which is such a flexible I don't know how to mention it. Like, this is programmable. You can add columns through an API, and within this you can actually have sort of like executable code which you can fetch through the API. You can run it on your end, get multiple collaborators onto the same document. So it's pretty good, right? And it comes with its own nice little templates which fit into business. So something like this. So if I go into my product launch Airtable, it's not just Excel, you know, it's a lot different. Like, these things, they are available as separate fields, right? It's almost like Excel with Trello on steroids, something like that, right? So this is like a product launch. So if you do product launch, quite a few like us, this will be a lot of useful stuff. Anyway, for now, since we're working with just the to-do app example, I created up a very basic one-column document. And you can see whatever I've been updating, I have connected it through something called a Zapier Zap. So that's the webhook integration that we will show you. So let's say I go to zapier.com. Alright, yeah. So this is, if you just scroll a little bit up ahead onto the contract web UI on Ethereum, you'll see this button called integrations. Sure. I already have it configured. Let me show it to you where it begins from. So you have to do something called make a zap. That's what you have to do. And over here, search for webhooks by Zapier. If you can't find it, just type out. I see it as premium, but I don't think it's a paid feature. I've been using it for a while. Okay, choose trigger event as second one. Wait for a new post put to a Zapier URL, and then you say catch hook, and then you say continue, right? And now you have something like this. Copy this URL, go into the integrations, enter this URL over here, and you add a webhook. Now let's just add a to-do item so that the Zapier it knows what data structure of webhooks to receive, right? Just sending out one more to do node which will cause an event to be emitted. Yeah, something like this, right? To do item added. Also, sorry to go back, make sure you select the deselect the all and only create the webhook for an item added. So basically whenever you add a new item, it should get populated into this. It's already happened, but let's see. Alright, so you entered this into the integrations tab, you selected the to do item added event on this, and just to send a sample data load, just execute one add to do and continue from here. Do a test and review on this. There you go. So you'll see that there is against the to do item added, which I did a little while ago, there is a corresponding event payload update like this, right? So just take this as the sample of data, right? Once you've done that, this part is done. Then I'm going to catch this hook and I'm adding it to a Airtable. Just if you don't see it there, just search for Airtable and select it. If you are new to this, you'll be asked to sign in to Airtable and connect it. So you have to go to Airtable, go into your account, and you have to generate your API key over here. So make sure, I'll give you a few minutes to kind of get through this. Connect it on Airtable, give it the right permissions, get that API key from there and enter it. So you'll be able to create. We're just looking at create for now. Like the toggle should ideally be also connected to an update. We'll look at that later on. But continue. Okay, this is where it will start asking which Airtable account, where to put it. So I made this untitled base. That's what I'm working on. Which table? There is only one that I created. And the note is exactly what's coming from this sample data. You can see. So let's pick up from event data. Event data node. So Zapier does this work of taking the JSON structure, like how it is coming through. Under event data, the fields are how you saw it, like this. There are further nested fields, item ID node. Zapier has this easy mode where it kind of shows you the event data dot node. So basically event underscore data dot node, it has nicely passed it into event data node. So that's exactly what you're going to enter into this Airtable and click on continue. So it wants to send a test record. It's not really necessary. I'll skip test because it's already tested. You can always test it out. And make sure you turn your zap on. Now the thing is, I have two zaps working, so I guess there are two zaps working right now. So it is possible that the next item that I enter will come in twice, right? Let's see. But think of this like a live to-do dashboard. Like whether I enter it from my web UI, as you can see, it's all connected no matter where you go. Yeah, so it got populated twice because we have added the webhook twice, but pretty pretty straightforward. So you saw, right, like while I was doing it live, I could go ahead make a toggle updated functionality without even being a front end developer as such, right? And I also managed to make sure that the checkboxes come and go as you keep toggling the state, and the Airtable update as well. And this is just to begin with the possibilities, right? As you could see that I could also connect update events, and from this coming into Airtable, a new record being added, you can also start to trigger further workflows based on it. Like let's say I have a certain string that should update a different Airtable, or it should alert someone that a new note has come in, like that, like send an SMS. That can also be done. For now, I'll switch off one of the integrations because I don't want both. So just go to the integrations dashboard and make sure the other slider stays off, so that next time I'm updating, this should not go through the same duplication. So here we are. It's pretty smooth. I'm not even a front-end developer, I'm not a JavaScript developer, but I could manage to build it up in less than an hour, I think, or almost an hour. Yeah, so with a fully reactive and working UI. So go through the code that I'll just commit it in a bit, and do send us an email, hello@blockvigil.com. My name is Anumit, and I was actually joined right now by my colleagues Samikshan and Swaroop. They also have been helping me because I'm not a JavaScript guy, so they're trying to prompt me from behind, trying to say certain things. We have more complex use cases that will start taking up for these webinars. This is just to introduce the concept of a dynamic UI and Airtable integrations. Do keep a lookout for our newsletters. Sign up on beta.ethvigil.com. Go there. You can just get an invite code for your account, and we allow you to access your Ethereum account through a decentralized wallet also, like MetaMask, or if you want to write your own Web3 JS code, you're welcome to do that. Just enter your email, get an invite code, you'll be signed up to all our updates coming up for developers, the new resources we keep putting up. Take a look at our GitHub. It has a lot of use cases, API usage examples. Docs are available at ethvigil.com/docs if you want to work deeper, and if you want to know what exactly Ethereum protocol is, what is a transaction, what is a smart contract, we have simplified the process further for you. So you can go to tutorials.ethvigil.com right over here. I already have a running account on this, but you can go ahead and sign up. So it gives you certain things to get started with. It's a live and interactive framework where we let you deploy a contract, and we start introducing concepts as you're going through this lesson. So think of it as a very hands-on yet deep into the protocol level knowledge, which you can work on improving your understanding of Ethereum and blockchain protocols in general, like what a transaction is, what a block is, where do they get added, do they cost something, and so on and so forth, right? So I'll hope to see you at the next live streaming event that we have. Keep in touch with us on Twitter or our Medium Engineering blog post, and do sign up for the developer account. Let's start building some things. Thank you for joining in. Have a nice day.